Tuscaloosa. Surrounding us, we have air, water, and trees. As scientists and engineers, we observe the world around us, which we innovate based off of what we measure.
Today, we're going to be talking about 4 fundamental quantities that are all around us all the time. We're going to learn about how we measure them and what we would use to measure them with. So today, we're going to be talking about these 4 fundamental quantities, which are time, length, mass, and lastly, temperature.
Let's take a closer look and head down to the water. What is a fundamental quantity? Well, a fundamental quantity is a physical quantity that doesn't depend on any other, making it independent. Let's look at some examples to make this definition make a little bit more sense. Let's take a look at time. That's our first fundamental quantity. Let's take a look at this clock.
We can measure time in minutes, hours, seconds, days, and so on. Time is an ongoing sequence of events taking place. For example, it's been about 20 seconds since we started talking about time.
Well, what about length? That is also a fundamental unit that we use in our everyday lives.
Well, for length, it's the distance between 2 points. We can use a tape measure to observe a certain length. This branch is roughly about 3 feet. To express a measurement, we need to make sure to have 2 things: a value and a unit. A value being any number, and a unit being any standard used to make comparisons in measurements, such as meters, feet, seconds, grams, even degrees Fahrenheit. How about these rocks? Well, one is heavier and bigger than the other, but how can I measure that? Mass is a measurement of how much matter is in an object. Well, clearly, we can see that the bigger rock has more matter than the smaller rock. So, when we say that the bigger rock has a mass of 900 grams and the smaller rock of 90 grams, we can actually see this by using a balance to measure the mass. The last fundamental quantity we'll cover today is temperature. Temperature is a measure of the hotness or coldness of a substance, and it depends on how fast particles in the object are moving. In water, particles are constantly sliding past each other. The faster they move, the hotter the temperature. The slower they move, the colder the temperature. So, imagine the lake. It's made up of millions of tiny little water particles. So, if I were to take a thermometer to measure the temperature today, the lake temperature would be roughly around 78 degrees Fahrenheit. 78 being the value, and degrees Fahrenheit being the unit. Let's recap. Today we learned about the 4 fundamental quantities, these being time, length, mass, and temperature. These quantities are independent of each other and cannot be used to measure each other. This means you can never convert directly between fundamental units, so you can't use a tape measure to find the temperature of the lake, or a watch to measure how much mass a rock may have. We also learned about how to express a measurement. You express it by using a value and a unit. Value being a number, and a unit being anything like feet, seconds, or grams. We also learned about time being expressed in seconds, length in feet, mass with grams, and temperature with degrees Fahrenheit. These measurements are made up of 2 different systems: the Imperial System and Standard System. The Imperial System is what we use here in America, like feet, inches, pounds, and degrees Fahrenheit. While the Standard System is what scientists use, like seconds, grams, meters, and Kelvin. We're going to dive more into these topics in our next